Today, objective will be to explore the production of radionuclides from both the research and the industrial perspectives to ensure that we have continuous supply and we have the necessary infrastructure to do so.
We as engineers are often focusing on technical solutions, on new ways of producing radioisotopes. Maybe we should go back to the essence of what we are doing is about curing people, helping people and beating cancer.
People are amazed. One of the things that they ask their doctor is, are you sure you've treated me? Because I've gone through chemo and that was horrible, and now you've injected me with this radioactive thing and I don't feel anything. And then the doctor shows them their scan and they go like, wow, this is amazing, the improvement.
It's, you know, this famous picture. I mean, you really have to realize that this came from here, in collaboration with Heidelberg.
When I started working in this field, we were talking mostly about iodine-133 and technetium-99m. And since then, the portfolio of radionuclides and radiopharmaceuticals was getting so broad.
But the evolution very recently has been towards the development of so-called theranostics, where the therapy is coupled to the diagnostic aspect. And why do we call it theranostics? Is because you use the same chemistry for the diagnosis and for the treatment. So if you can see the tumor, you're treating the tumor.
Now we have a new radiopharmaceutical for rare disease as neuroendocrine tumor, so the lutetium label peptide, but also now for prostate cancer. So prostate cancer is changing our reality because we are getting out of a small number of patients that we need to treat, and we are entering a disease that is very common, particularly a disease that might be treated.
Now, the reason why we are facing a shortage is simply because there is the aging of infrastructure producing the radioisotope for medicine.
And this is mainly related to the fact that we have reactors that have been built in earlier stages, and due to the political changes over time, there was not enough attention in a proper planning of their upgrade or new one building.
Le RGH a aussi beaucoup souffert de cette mauvaise presse du nucléaire. C'est pour ça qu'on a eu plusieurs retards. Les politiciens ne voulaient pas forcément continuer dans cette voie, dans ce projet.
And this has, in a way, caused a delay in the application of certain type of treatment and in the planning of the proper supply of the isotope that the medical community is currently needed.
The existing reactors need maintenance, they need upgrades, etc. So breaks in their operations are also unavoidable.
And when that happens and the coordination between the reactors breaks down for that reason, then for several weeks there is no supply of a certain radioisotope, and all the other stocks of that radioisotope, they decay away, and then the patients can no longer be helped, of course. So.
I'm working close to Milan. That is a super busy area, traffic jam every time. When the car is bringing the radiopharmaceutical from my radiopharmacy in Monza to my hospital in Bergamo, if there is an accident, I get half of the activity, and I can scan half of the patient.
It's just-in-time supply chain, on hour-to-hour, accurate deliveries, but we need also to be just in time with the infrastructures for the future, right? So we need really structural improvements in this supply chain.
In Spain, we have a very paradigmatic example, that is the transplant network. It worked efficiently. The radiotherapy should follow this procedure. A network of hospitals and decision takers can work together.
Ideas are fantastic, innovation is fantastic. If there is not a little bit of money to transform the good ideas into concrete, practical, manageable projects and make them live, we have a problem.
In order to produce the isotopes, there is a quite costly infrastructure required.
Because it's not only the production of radionuclides.
In between, there is a long story.
Someone has to process the radionuclide, someone has to make a radiopharmaceutical out of it, offer it, get the marketing authorization, bring it to the hospital. And there are, again, procedures at the hospital. So it's a long chain of contributors to that.
Public funding can help kickstart it, can help for the validation for the, let's say, proof of principle. But as soon as we want to make sure that the supply chain, the production and the treatment is sustainable, we shouldn't hide it. There shall be some financial gain needed.
So on one hand, the lives of our patients, and the other hand, the production in a safe way, taking strategic autonomy as a European objective in this field.
Luckily, the JRC can strongly help to the Commission on that.
What we will do now is to sum up all the feedback that we have received, and then to look how we can, on one hand, convey to the policymakers in the European Commission.
And the fact that the JRC is independent of national interests and is part of the European Commission, but with the scientific background, this reassures the different stakeholders.
And also, I think the idea was really giving people the output of what they are doing every day, which also create motivation. Because if I'm staying all day sitting in a lab and I do not see the final result of what I'm doing, I might consider that my work is not so important. And indeed, in this work, every single step is crucial.
But bringing them together, having them exchange, finding common grounds, this is the way to go forward, to find ways how can we ramp up the production, how can we refine, how can we, for the well of the citizen, work together and fight together the cancer.
Le mot de la fin, c'est que tous les acteurs aient conscience qu'in fine, il y a un patient derrière et qu'il faut qu'on travaille tous ensemble, main dans la main.
We want to save lives.